Hi, I'm Nivedita here. In 301 Organic Reaction Mechanism, Unit 2 Free Radical Chemistry. In free radical chemistry, we will discuss some topics that are free radical reactions, free radical properties, free radical mechanisms in general, free radical substitution mechanism, neighboring group assistance in free reactions. Let us know about the free radical definition. It defines that a free radical can be defined as any molecular species capable of independent existence that contains an unpaired electrons in an atomic orbital, means which the atom having a unpaired electron is called free radical. Example: in presence of thermal homolysis or UV, it forms carbon free radical plus halogen free radical. So it forms carbon and halogen free radical. Let us know the some top properties of the free radical. First one, in gaseous state, free radicals are easily formed. In gaseous state, the radicals will easily formed. Most of them are formed in non-polar solvents. Short-lived radicals are difficult to isolate because they are highly reactive. Why they are highly reactive means in the presence of unpaired electron results in a certain common properties that are shared by most radicals. Many radicals are unstable and highly reactive. The structure of free radicals are planar and pyramidal. The structure of free radical is planar. When planar, they have sp2 hybridization. The pyramidal, they having sp3 hybridization. Unpaired electron cause radicals to be highly reactive. Because of presence of unpaired electrons, they have highly reactive. Unpaired electron cause radicals to be highly reactive because they have short-lived radicals are easily formed. Long-lived radicals are stable. Long-lived radicals are stable because they exist in equilibrium with normal compound. So that they are long-lived or stable. There, we can discuss some properties is there. They can either donate an electron or accept an electron from other molecules. They behave as accidents or reductants. The most important is oxygen containing free radical in many states are hydroxy radical, superoxide anion radical, hydrogen peroxide, oxygen singlet, hypochlorite, nitric acid. These are the examples which containing the free radicals in many states. Let us discuss about general mechanism of free radical reaction. The free radical reaction, they consist of three steps: chain initiation, chain propagation and chain termination. The chain initiation, it is the first step. It involves the formation of free radicals, usually by homolytic cleavage of bond. That's a cleavage in which each fragment retains one electron. It may happen spontaneously or induce heat or light. We can see that we can see in the first step, in the presence of heat or light, they give two types of radicals: A radical plus B radical. In second step, we can see that it describes the chain reaction. Once a reaction free radical is generated, it can react with one the radical is reactive radical is generated. It can react with the stable molecules to form a new bond. It forms a new bond, and then they go and generate a free radical. So one propagation step often involves hydrogen abstraction or addition of the radical to give a double bonds. Same year also takes place. The new bond is formed between D and he. The last step is chain termination. This step it is the opposite of first step. Here in first step the two bond A and B bonds forms a two free radical. Here two radical forms a new bond. Means that like two like or unlike radicals form a new bond. This only the chain propagation describes the chain part of chain reactions. Once a reactive free radical is generated, it can react with a stable molecule to form a new free radical. Third step it involves the destruction of free radicals. This usually happens by the process of opposing to the first, namely radicals to form a new bond. Next, we will discuss about the free radical substitution reaction substitution mechanism. It also involves the three steps: chain propagation, chain initiation, chain propagation, and chain termination. Let us know the definition of the substitution reactions. These are the substitution means these are the radicals in which one atom in a molecule is replaced by another atom or group of atom of free radical. Substitution for purpose involves a breaking of carbon or hydrogen bond in alkanes such as methane. That's called a substitution reaction. In that the first step involves the chain initiation. Example, we will take chlorine. Chlorine and the presence of light, it gives two chlorine free radical. In the first step, it is an initiation reaction. Here, chlorine is react in the presence of light, it gives a two chlorine free radical. Next is chain propagation step. Chlorine free radical reacted with the CH4 to give HCl. One of the H is gives rise to HCl because chlorine a free radical and form chlorine CH3 free radical. Once again, CH3 free radicals react with chlorine. It forms chlorine free radical. In last step, when this is the opposite of the first step, na chain termination step. So chlorine plus chlorine reacted to gives an chlorine free radical, it forms a bond and gives rise to Cl2. Like same thing, methyl free radical gives rise to bond with the CH3. Like that, chlorine plus CH3 forms the bond with CH3Cl. So here the chain termination step is the opposite of initiation step. Neighboring group assistance in a free radical reactions. Let us know the definition of the neighboring group participation. It defines that the direct interaction of the reaction center with the lone pair of electrons of an atom or with the electron of a sigma or pi bond contained within the parent molecule but not conjugated with the reaction center. It's called neighboring group participation. So it is also called as NGP. In here we will see the reactions. Rx forms R free radical and halogen. Second step it forms same reaction. So the first step is called as a cleavage. Cleavage takes place. Second one is abstraction. It forms a new bond with another molecule. And the photolytic halogenation is a process that normally leads to mixture of many products. Like in the presence of H nu, it forms a new bond. However, in NGP, the bromination of carbon chains containing a bromine atom occurs with high regioselectivity bromination of allyl bromide to give 84 to 94% substitution at the carbon adjacent to the bromine. Already in the molecule, this results especially surprising because position is close to polar groups such as bromine should actually deactivated by the electron withdrawing field affect the bromine. we can see in the reaction bromine in this C we can see in the bromine free radical gets on the bromine free radical and another it's react with this molecule to form a epoxide. This bromine will go and attach to the hydrogen molecule and it forms like a abstraction. Then it forms bromine will eliminate it to form the epoxide. Then it form the in these unusual regional selectivity is explained by the mechanism of abstraction. In the normal much, bromine abstracts the hydrogen from right side by leaving R. When bromine is present in the proper position, it assists in the process giving a cyclic intermediate or a bridged free radical. In the final step, R similar to the R free radical reacted with bromine to form a bond between the bromine, the ring will be the broken. This mechanism is correct in the configuration of substituted carbon should be retained. Thank you.